Hi there, my name is Michael O'Neill, and this presentation details the work involved in developing a streamlined volumetric analysis pathway of MRI brains for epilepsy patients. Epilepsy affects approximately 40,000 people in Ireland. For the majority of epilepsy patients, their condition can be managed with anti-epileptic drugs. However, for 30% of this population, anti-epileptic drugs alone are not enough to manage their condition, and they may need further intervention, such as neurosurgery. In Beaumont, patients will get referred for a 3T epilepsy protocol MRI when they initially present. Among other sequences, this contains a high-resolution T1 weighted MP range. The MRI is reported as either normal or abnormal, and is also used for subcortical segmentation to yield volume estimates. Structures of particular relevance in epilepsy are listed here. A reduction in the volumes of these structures can help to indicate sclerosis or significant volume loss that is difficult to identify by volume assessment alone. Using volumetric analysis in this fashion has been shown to augment the clinical profile and contribute to a successful surgical decision by providing concordance to video EEG data and neuropsychological assessments. For an accurate comparison, we needed to create a normal database consisting of volumetrics from a range of healthy subjects. The database would be subdivided by gender and age, with a minimum of 11 patients per subgroup. This was indicated by a power analysis to achieve statistical significance. The database would serve as a comparison tool for patients in the epilepsy workflow undergoing volumetric analysis. Clinicians were consulted to establish criteria for patient selection. Over 200 subjects with scans reported as normal by a radiologist with more than 10 years' experience were included. All patients underwent the same protocol on a 3T Siemens Skyra MRI with the same parameters shown here in the table. Two different structural segmentation and volumetric calculation algorithms were tested. Once the normal database was created, it yielded confidence intervals for each of our structures of interest. But in 2021, new medical device regulations came into effect in Ireland, and this meant that non-CE mark software could not be used in the clinical setting. This ultimately led to our decision to choose Brainlab Elements as our volume calculator, as FreeSurfer is open source. The final database consists of over 200 patients, split by gender and age, with 20 structural volumes calculated per study. The structures calculated can be seen in the images here. We were interested in exploring the effect of anonymization on volume calculation. While no statistically significant difference was found between the groups, some individuals were found to have volumes altered. The graph below shows the difference in anonymous and unanonymous female patient whole brain volumes. Because our normal database is divided into age groups, we can estimate how volumes change over time. We can see a general trend that grey matter structures within the brain have smaller volumes in older patients, while the ventricles, which are fluid-filled structures, get larger in older patients. With the database in place, a Python script was developed to automatically collect the results and collate them into a report. The report compares hemispheric structural ratios and highlights volumes which may fall outside of normal ranges for age and gender. The final workflow that's used clinically is shown here. The script takes the volume calculations from Brainlab and the normal database information for the specific age and gender of the patient, and it then collates all this information into a patient-specific volumetric report. An example volumetric report is shown here. Ratios are calculated for the relevant epileptic structures as previously discussed, and the database comparison indicates values in red as those being outside of the normal range. A comments section summarizes the data for clinicians. Future work for this project includes the incorporation of T2 weighted images for a more accurate structure delineation. We also want to expand on the number of people in the normal database and work with the company to develop a way of measuring cortical thickness to identify regions of focal cortical dysplasia, which is abnormal changes in cortical thickness, relevant in epilepsy also. Here are some references relevant to this work, and thank you for listening.